All right, the first question, and actually number 1 and number 2 are the same directions. We're asked to simplify this down to a single trig function. In other words, you got more than one trig function, do something so that it gets down to 1. So in number 1, the first identity I can think of for cosecant is 1 over sine times sine, and those actually divide out, and I'm left with 1. Over here with cotangent squared plus cotangent tangent, well, cotangent and tangent kind of remind me of cosecant secant. Those are reciprocal identities, so I should, if I rewrite cotangent, I should be able to divide out the tangents, which I can. So I end up with cotangent squared plus 1. That's another identity, and that's actually equal to cosecant squared t, or x. I'm sorry, we're in x's now, aren't we? All right, number 3, so now we're under different directions. Number 3 says to factor. So a lot of students just kind of start applying identities and think they know the answer. Well, I just want to see evidence that you know how to factor this. Well, this is an illustration of difference of two squares. So it's secant x minus tangent x times secant x plus tangent x. That's all I wanted on that one. Okay, number 4, I'm asked to multiply by the conjugate. So you have to understand what the conjugate is. The conjugate in this case would come from the denominator, and that would be 1 plus sine t. And as far as the denominator goes, this actually is an illustration of difference of two squares. So I'm just going to keep the numerator the way it is, just because I know where we're going with this. And so if I FOIL 1 minus sine and 1 plus sine, I get 1 minus sine squared. And then I'm just going to simplify from here. So 1 minus sine t, or 1 minus sine squared is cosine squared. And the cosines divide out. So I'm left with 1 plus sine t. And so that's your final answer. Under number 5, first task is to recognize the identity that they want us to use. And this is the sum of sine identity. Now let me jump up to the directions. We're going to rewrite as a constant or a single trig or some function of x. So keep writing it down to keep using trig identities till we recognize one of those 3 cases. So sum of sine says sine of pi halves times cosine of x get that in there plus cosine of pi halves times sine of x. Okay, so then from here I just want to identify what is sine of pi halves. So sine of pi halves, let's see, would be 1 times cosine. And cosine of pi halves would be 0. Now obviously anything times 0 is 0. So at that point, that half is done and we're just left with cosine of x. Number 6, we're asked, again, the same thing, asked to identify what we're looking at. Well, cosine, sine, that would be difference of cosine. So 100 minus 70. And so that's cosine of 30 degrees. So cosine of 30 is square root 3 over 2. Okay, tangent, sum of tangent. So that's tangent of 180 plus tangent of x over 1 minus tangent of 180 times tangent of x. Well, let's see, tangent of 180 would be 0 over -1, so that's actually 0. So this becomes 0, and that becomes 0. So up top, I'm left with tangent x divided by 1, so it's just tangent x. Okay, 2 cosine squared, 15 degrees minus 1. That's actually a form of the double angle of cosine. So that's cosine of 2 times 15, which is cosine of 30 degrees. Hey, we've seen this one before. So that's square root 3 over 2. All right, number 9, you have to recognize that you're looking at a form of the half angle. And we're looking at, I believe, sine. So 1 minus, yeah. So we're looking at sine of 10x over 2. So it's just sine of 5x. Okay. And then lastly, number 10, it almost looks like double sine. The problem is it should say 2 times sine theta cosine theta. So what I'm going to do is I'm going to put a 2 there. Now the problem is I just can't do that. Just because I wanted to there doesn't mean I can always put it there. There's a consequence to that. So to balance it out, I'm also going to divide by 2. So in essence, I'm going to write 1/2 times 2, which in total, I didn't really change anything. I just put these extra 2 numbers there that weren't there before. But now, this piece, the 2 sine cosine, is an illustration of a double angle. Okay, so I have this extra 1/2 out front, and this is 2 times the sine of the double of 22.5 degrees. So that's 1/2 times, oops, I'm sorry, the 2 is not there in the double angle, is it? So sine of 45 degrees, so 1/2 times the square root 2 over 2, which is the square root 2 over 4. So that's the final answer for that one. Verifying identities can be, for some, a lot of fun. So if you've not attempted these yet, I strongly encourage you to stop and not watch the solution. It's kind of like having someone tell you a joke. Once you've heard the punchline, there's you get the joke, and there's no reason to continue to do anything else more with the problem. So again, if you haven't tried it, try it before you watch me work it out. So number 11, the trick here is we're going to factor out cosine from the numerator. 1 minus cosine squared over sine x. Then we're going to convert that 1 minus cosine into sine squared. Now one of those signs are going to divide out, and I'm left with cosine times sine. And mathematically, switching order does not change the value of a product. So they match, and I am done. Number 12. Okay, so same trick we kind of did a second ago. I'm going to replace cosine squared with 1 minus sine squared over 1 minus sine x. And this time I'm going to use difference of 2 squares to factor out, to split up the 1 minus sine x, sine squared. So that'll be 1 minus sine x times 1 plus sine x all over 1 minus sine x. And what do we notice? We notice the 1 minus sine x divides out, and we're left with 1 plus sine x, which is exactly what we were trying to show. Okay, number 13, cosine 2x secant x equals 2 cosine x minus secant x. Okay, well, I'm going to go ahead and use a form of the double angle of cosine, And I know there's got to be a minus in there, and I got to pull a 2 in there. So I'm going to do the form where it says 2 cosine squared x minus 1 times secant x. You know, there's 3 forms for the double angle of cosine. One of them has a 2 out front. So again, that's what I was trying to lean towards. Then I'm going to distribute that in. So that would be 2 cosine squared times secant x minus 1 times secant x. And when I do that, I'm going to pull apart one of these cosines to multiply with the secant x. Because again, this piece right there, those are reciprocal identities, so that actually equals 1. So I get 2 cosine x minus secant x. And so we're done. We got it the left side to match the right side. All right, and then number 14, I'm going to go ahead and use a difference of 2 squares. So cotangent x minus tangent x, and then cotangent x plus tangent x, all over cotangent minus tangent. All right, well, at this point, the cotangent minus tangent divides out, and I'm left with the cotangent x plus the tangent x, and I'm going to rewrite this in terms of sines and cosines. So actually, no, I'm not. I lied. I'm going to rewrite cotangent as 1 over tangent plus tangent. And then I want to make a common denominator out of this because I want the denominator to say tangent. So I'm going to multiply by tan x over tan x, just with that one statement. And so if I multiply them together, I get 1 plus tangent squared x over tan x. And 1 plus tangent squared is secant squared, yay, over tan x. Okay, so we were able to work it out. All right, number 15, I want to bring the cosine over. So cosine cubed minus cosine theta. And then I want to factor out a cosine. So I get cosine theta times cosine squared theta minus 1. And then I want to use difference of 2 squares again. So cosine theta minus 1 and cosine theta plus 1. And then I want to split that up into 3 factors, so set up 3 different equations. So I have cosine theta equals 0. Then I have cosine theta equals 1, and cosine theta equals negative 1. Okay, so let's see, where am I talking? If cosine theta is 0, so that means I'm up there and down there. Cosine theta is 1 puts me that side, and that's negative 1. Okay, so theta is going to be 0, pi halves, pi, and 3 pi over 2. Number 2, cosine 2x equals sine x. All right, so in this case, I'm going to go ahead and just use a double angle identity. And I like the, well, let's see. Let's do cosine squared minus sine squared equals sine x. Again, there's multiple ways to get this. And then let's rewrite the cosine squared as 1 minus sine squared minus the sine squared equals sine x. And then let's just get all these guys together. So if I bring, let's bring the sine squareds over and the 1 over. Okay, so that's 0 equals 2 sine squared x plus sine x minus 1. And then I want to go ahead and factor that. So that would be, let's see, it has to be 2 sine x and sine x. Has to be a 1 and a 1. I want that to be plus and that to be minus. Double check that in my head real quick. Plus 2 minus, okay, that's right, that works. So I get sine x equals a half, and I get sine x equals -1. Alright, well, as far as the half goes, it's got to be the first and the second, and I'm looking at that. And then as far as the -1 goes, the only place where it's -1 is down there. And so the angles that I am looking at would be square root 3 over 2. I'm sorry, that would be that'd be the cosine value. I'm looking at pi sixth, 5 pi 6, and 3 pi halves.